This video is on how to graph in standard form, topic number 13, standard form of a quadratic. So, we discussed vertex form and intercept form of a quadratic. This is our third form called standard form. Out of the three different forms, this is the form that gives us the least amount of information that helps us find a graph. We still know that the positive a value means a graph opens up and negative means it opens down. We still know that if a is greater than 1, it's a stretch. A is equal to 1, it's normal, or if it's between 0 and 1, that it's a compression. That has not changed over the forms. The two new values we are given is b, which is just a coefficient of the linear term, so it's the coefficient in front of the x. It doesn't tell us anything about the graph, but it is helpful when we actually find the vertex, which we'll cover in a minute. The really only useful piece of information we can get from the standard form is the c value. And the c value, the number at the very end, the constant term, is our y-intercept. So we're able to pull the y-intercept from the graph. So just jumping ahead, let's take a look at example B here. If I were to go ahead and label the a value, which is -2, b we see is -4, and c is +2, the only useful piece of information I can get directly from the form is I know that this is the y-intercept value, 0, 2. So I come down here and put a dot on the graph at 0, 2. That's it. That's all the form gives us directly from the equation, as we can figure out what the y-intercept is going to be. So we can automatically see that we have a bit of an issue in terms of how do I generate the rest of the graph if I'm only given 1 point, and not even the middle of the graph, just a y-intercept. Well, we're going to do what we did with intercept form, in that we're going to try to find the vertex, the middle of the graph, and then graph it just like we would in vertex form. So the way we go from standard form, the one that we're given, and turn it into vertex form, essentially, finding our HK value, is we're going to go ahead and use the following 3 steps. So first of all, we know the a value is the same. Well, what does that mean? Well, that means once we find HK, we can just know that the a value affects our quadratic pattern of 1, 1, 2, 4, 3, 9, and we can get the rest of the graph from there. So really what we're focusing on is figuring out what the h value is going to be of my vertex, and also what the k value is going to be of my vertex. So for the h value, we're going to use the formula h is equal to -1 times b, the b value, divided by 2 times the a value. Now for the k value, we're going to do what we did in intercept form as well, and we're going to plug our h value into the equation and simplify down. So we're going to find an x value in the h, and we're going to find a y value of the k. Now, a quick little note on this h value, -1 times b over 2a. This isn't just some random formula that we made up. You have seen this before from the quadratic formula back in Algebra 1. -b plus or minus the square root of b squared minus 4ac all over 2a. Now, all we are doing is, with this negative in front, I'm just adding in a -1, because that's really the value that's there. So -1 times b over 2a. So really, we're just using this portion of the quadratic formula to help us find the x value of our vertex. So we're not making this up, we're just using a piece of information that we had learned before to help us figure out the h value of our vertex. So that, once I use this formula to find h, I plug it into the equation to find k. From there we can plot our hk value and use our quadratic pattern that's affected by the a value to get the rest of the graph. So let's come down and let's keep working on example B here. So I've listed the steps for us. We're going to start off by saying we have our y-intercept, but we want to find hk. To find h, we're going to use the formula h equals -1 times b divided by 2a. For k, we're going to plug in that h value to figure out what the k is going to be, basically do some math. And then from there, once we have the vertex graph, we can just use our normal quadratic pattern. So let's find h, which is a value of -1. Now what that means is we know that our vertex falls at -1 somewhere. We don't know where exactly, so we need to figure out the k value. So we're going to plug it in, h is -1, into our original equation, and we're going to simplify. Using order of operations, we're going to do our exponents first. So -1 squared is 1. We're then going to do multiplication, and then we're going to do addition, subtraction all the way across, giving us a k value is equal to 6. So that means I know 4. So we know our k value is 4, meaning our vertex is at -1, +4. From here, we can just do our normal quadratic graphing using the a pattern. A value is equal to -2. So from here, we can go 1 down 2 in both directions, because normally we go up 1. 1 times negative 2 is negative 2. Instead of going over 2 and up 4, we're going to do 4 times negative 2, which means negative 8. So we'll come down here and go down 8 in each direction. And from there, we will get our quadratic pattern. Okay, just it there. So once we get it into vertex form, we're just going to use our normal graphing way, just like we graphed into vertex form. Right? So we're going to use the old method once I find h and k. The only thing new that we're doing today is we're using a formula to figure out what the h value is equal to. The only other piece of information we need to know how to do is write the equation in standard form. We never write it in standard form, though. We always write it in intercept or vertex form first and then convert. So I'm going to use vertex form to start. For this particular equation, we could say y is equal to x plus 2 squared minus 3, because my vertex here is at negative 2, negative 3. Figuring out the a value, we go over 2 and we go up 2. Normally we go over 2 and up 4, so this is in fact a half the value of what's normally happening for us. So I get 1/2 times x plus 2 squared minus 3. So all we're going to do now to convert is we're just going to multiply, square, everything that we need to do just algebraically to figure this out. So using exponents first, I need to go ahead and do x plus 2 squared, which means that we do x plus 2 times x plus 2. That's what it means to square something. I distribute, multiple distributive property, x squared plus 2x plus 2x plus 4, giving me x squared plus 4x plus 4. So again, this was all the stuff that was happening in the parentheses in yellow. I still have that 1/2 in front, and I still have that minus 3 at the end. Well, order of operations says we need to do multiplication next, so I'm going to distribute the 1/2 to each. So 1/2 x squared plus 2x plus 2. And I still have that pesky minus 3 on the end, so now we'll combine like terms in the very last step, giving me an equation y is equal to 1/2 x squared plus 2x minus 1. So we never directly write anything in standard form. We always write it in either vertex or intercept, and then we just algebraically convert down to standard form by squaring, distributing, and combining like terms.